Now that we've talked about the component vectors for three-dimensional space and how to take their cross product, let's look at three different ways to calculate the cross product of two vectors. The first way I'm going to do is using the component vectors. So let's consider -5, 4, 0 crossed with 0, 3, 5. If I write these in terms of their components, this first one is -5i plus 4j, and I have 0 k's here. Crossed with, I have 0 i's, 3 j's, and 5 k's. The fact that this uses the distributive property, and we know that holds for the cross product, means I can just FOIL this. -5 times 3 is -15, and my first coordinates would be I cross j. The outside, -5 times -5 is -25, and then I have an I cross k. My inside, 4 times 3 is 12, and I have j cross j. Finally, my last, 4 times 5 is 20, and then that's a j cross k. I cross j is equal to k. I cross k is equal to -j. Anything crossed with itself is equal to 0, so this term here is going to go to 0. And j cross k is equal to I. So we end up with 20i plus 25j minus 15k, or 20, 25, -15. The second way I want to look at the cross product, I'm going to refer to my verse vector u as u1, u2, u3. My second vector v is v1, v2, v3. The second way involves a formula. The formula for the cross product with two vectors is u2, v3 minus u3, v2 times I minus u1, v3 minus u3, v1 times j plus u1, v2 minus u2, v1, k. And we can use this formula to find the cross product. If I once again consider my vectors -5, 4, 0 and 0, 3, 5, in this case, -5 is u1, 4 is u2, 0 is u3, 0 is v1, 3 is v2, and 5 is v3. So when I use this formula, u2 times v3, that would be 4 times 5, minus u3 times v2, minus 0 times 3, times I, minus u1 v3, that's -5 times -5 times 5, minus u3 times v1, 0 times 0, j, plus u1 times v2, that's -5 times 3, minus u2 times v1, 4 times 0, k. Simplifying, this is a 20i minus -25j minus 15k, or 20i plus 25j minus 15k, which is exactly what we got in the previous example. My third method involves the determinant of a matrix. If I have a general matrix, I denote the determinant by vertical bars. And I'm going to look at the determinant of a 2 by 2 matrix, A, B, C, D. Its determinant is AD minus BC. We can think about it as multiplying across the main diagonal minus multiplying along the opposite diagonal. So for my vectors U, which is U1, U2, U3, and V, which is V1, V2, V3, the cross product U cross V can be done by finding determinants. This is the determinant of U2, U3, V2, V3 times I minus the determinant of U1, U3, V1, V3 times J plus the determinant of U1, U2, V1, V2 times K. We can think about this as we ignore the first coordinate times I, ignore the second coordinate times J, ignore the third coordinate times K. So we'll slowly ignore each coordinate. Let's go back to the example we've been doing. -5, 4, 0, cross 0, 3, 5. Using the determinant method, we'll ignore the first coordinates. So we have 4, 0 and 3, 5 times I minus, we'll then ignore the second coordinates. That'll give us -5, 0, 0, 5 times J plus ignore the third coordinates. That'll give us -5, 4 and 0, 3 times K. As I multiply these, I would have 4 times 5 minus 3 times 0 times I minus -5 times 5 minus 0 times 0 times J plus -5 times 3 minus 4 times 0 times K. And we can see this once again simplifies to 20I plus 25J minus 15K.